Lesson 3.4, what we're going to be doing is we're solving multi-step equations. Now, we've already done this in lesson 3.3, okay? So basically, we're still doing the same thing. We've just got something that is a little bit different. And what that is we're going to have variables on both sides of the equation. But before we get into anything like that, let's go over what we learned in 3.3. This one statement that you need to remember. What do we always do first when we're solving a multi-step equation? William? Add like terms. Perfect. Add like terms. Now, there's one exception to that. And it's when you see what in your problem that you have to take care of first. No.
Parentheses or distributive property.
Distributive property. Anytime you see distributive property, you've got to do that first. But in any other case, you would always combine like terms first, and then you can solve. So we're going to follow that exact same rule for what we're doing today. So look at example 1. Okay, everybody write these down. This first problem here, what are my like terms? I've got two sets of like terms. William, tell me my first set.
7x and negative 2x.
Perfect. 7x and negative 2x. What is my second set of like terms? Vincent?
19 and 55.
Very good. 19 and 55. Now look at these two sets of like terms. My 7x and negative 2x, they're on opposite sides. My 19 and my 55 are on opposite sides. That's not a big deal for us. We know how to move things. We do inverse operation. Still the exact same thing. This is the one thing that you've got to remember, though. We want to get all of our variables on one side and all of our numbers on the other. Now, it doesn't matter which side, as long as the variables are on one side and the regular numbers or the constants are on the others. You say, okay, what do you mean by that? Well, let's think about it. Let's try to combine our like terms first, because we know we've always got to do that. So how do I combine 7x and negative 2x? What would I need to do? Vincent?
Add on both sides.
And what am I adding on both sides?
Negative 2x.
Okay, so I'm going to add 2x to both sides. Now, let me ask you this. Could I have subtracted 7x and moved it over to combine with the negative 2x?
Yes.
Yeah? You would get the same exact final answer as the rest of us if you did it that way. So now we have 9x plus 19 equals 55. I've still got a set of like terms. I put them in the same color so it would be very easy for you to figure out what they are. 19 and 55. What am I going to do to combine those terms?
Subtract 19 on both sides.
Very good. I subtract 19. Now, why couldn't I have subtracted 55?
Because if you subtract 55, there's no number on it.
Because there would be nothing left on this right-hand side, and we cannot have that. Okay? So now I have 9x is equal to 36. Now I solve just like we did back when we did lesson 3.2. How do I get the x by itself? Divide by 9. And x is equal to 4. Now let's say you want to check this problem. What you do in order to check it, okay, is you just plug it in. So I would say 7 times 4 plus 19. If you plug that in your calculator, you would get that your answer is 47. Now we know that the other side of the equation says negative 2, I'm going to write it underneath it here, negative 2 times 4 plus 55. Plug that in your calculator. What do you get? 47. So I know because 47 equals 47, I got the right answer. It checks out. Okay? All right, let's go to the next problem here. Sarah, what is my first set of like terms?
6x and negative 3x.
Perfect. 6x and negative 3x. Stephanie, what is my second set of like terms?
22 and 31.
22 and 31. Perfect. How would I get these to combine, William? Tell me, what would I do first?
You would add 3x to both sides.
Very good. Add 3x to both sides. And I get what? 9x
22
plus 22
equals 31.
equals 31. Very good. Now my other like terms are what, Blaine? 22 and 31. And how do I get those to combine?
Subtract 22.
Very good. Subtract 22 on both sides. So now I'm left with 9x is equal to what? 9. Very good. So then I
Divide on both sides.
divide both sides by 9 and get x is equal to 1. Okay? So example 2, we're going to do the exact same thing that we did in the other example. But how many like terms do I have in this one? One set. I know that those like terms are what? Negative 9y and 6y. Does 80 have any like terms to combine with? No. So it's not going to move. I am not touching 80 because I can't move it because he's got nobody to combine with. So what am I going to do with the negative 9? Add it to both sides. Perfect. Why couldn't I have subtracted the 6y? That would leave nothing on the side, and I can't have that. So now I have 80 equals 15y. I'm going to do what? Divide by 15. Now, will 15 go into 80 an even amount of times? No. So this is where we're going to have to reduce our fraction. And I got to think about it. What is the biggest number that will go into 15 and 80? 5. So I say, okay, I'm going to divide both of these by 5. What's 80 divided by 5? 16. What's 15 divided by 5? 3. There's my final answer. Also, you could write it as y equals 5 and 1/3. Either one of these are correct answers. Okay? So next example. Valentina, what are my like terms?
My like terms are negative 12w and 6w.
Very good. How would I get those to combine, Cole?
93 with, oh, I can't see. You would, minus, no. I would move, negative 12y and 6y on the same side.
Okay, and how would you do that? How would you move it?
I would swap 6w and 64.
Okay, we can't ever just swap something. So how do I get this 12w to move over to this side? What would I do? We got to do
Add 24. No,
add 12w. Very good. So we add 12w to this side, and I get 64 is equal to 18w. All right, Nishan, what would I do now?
You would divide by 18 on both sides.
Very good. Divide by 18 on both sides. And can 18 go into 64 an even amount of times?
No.
No. So what is the biggest number that will go into both of these? 2. Can't be any bigger than that because 4, 6, 8, 10, 12, nothing else goes into it. So we divide by 2 on both sides. 64 divided by 2 is 32. And 18 divided by 2 is 9. You could also have 3 and 5/9 as your answer. Either one of these answers are correct. The last example that we are going to do today is it takes everything that we have learned so far in chapter 3 and puts it into one problem. Okay? Yes, you will have problems like this on your test and on your quiz. Because what math is it's basically a staircase, pretty much. Whatever we learned on the first floor, then we're going to need it to go higher and higher and higher, and it keeps building on one another and takes you to where you need to go. So we learned our base in 3.1. We added a little bit to it in 3.2, a little more in 3.3, a little more in 3.4. So now we've got it all together, and let's see if you can put all the pieces together. What do you see that you need to do first, Vincent?
You have to distribute.
You have to do distributive property, because remember, that always trumps combining like terms when you see distributive property. But how many places do I need to do distributive property on? 2. So we've got to distribute our 4, and we've got to distribute our -2. So 4 times 1 is 4. 4 times -x is -4x, then plus 3x, equals -2 times x is -2x. -2 times +1 is -2. Make sure you have your signs right. If you don't have your signs right, okay, your entire problem will be off. Now let's look for our like terms. How many like terms do I have in this problem? Cole?
5 is all.
Okay, well let's say, how many in the first set do I have? If we're using the variables as our first set. 3, okay? We've got -4x and 3x and -2x. Which one of these, or which set, I guess I should say, which 2 should I combine first? Stephanie? Perfect, -4x and 3x. And the reason why we do that is because they're on the same side. So now I have 4. What's -4x plus 3x? -1x equals -2x minus 2. I've still got like terms, so I would either add 1x to both sides or add 2x to both sides. Which one do you want to do?
I'd add 1x.
Okay, let's add 1x to both sides. Now, if you say, wait a second, I wanted to add 2x, try it out. See if you get the same answer as us, because you should, as long as you do your math correctly. So now I have 4 equals, what's -2 plus 1?
1x.
-1x minus 2. Now, because I did that, I need to add 2 on both sides, and I get 6 is equal to -1x. What would I do now?
You swap them because you have to have the variable in one.
Divide by -1, and x is equal to -6. Okay? Now, if you did this the other way, I'm going to go back to this step right here. So if I were to go back to 4 minus 1x equals -2x minus 2, and you said, I want to add 2x on both sides. So we add 2x, I get 4 plus 1x equals -2. Then I would subtract 4, and I would get 1x is equal to -6. Well, I don't technically need to divide by 1. So did I end up getting the same answer? Yes. So you know that's a possibility to do it either way. Okay? Let's do the last one on this page. Look carefully at this problem. Carefully at this problem. There's something hiding that we cannot see, but we know is there. Valentina, what is it?
It's the one behind the distributive property.
Very good. It is the one that is right there. It says 6y minus the quantity of 3y minus 6. That technically means that there is a 1 there. It's not written, but I know it is. So I have to do distributive property. So I have 6y minus 3y plus 6 equals 5y minus 4. I need to combine like terms. My like terms are 6 6y, negative 3y, and 5y. Well, I'm going to combine the ones that are on the same side first. So what's 6y minus 3y? 3y. Okay, what would you like to do now? William?
You would add 4 to each side.
Okay, we want to add 4 to each side. You said, wait a second, I still have my y's. That's okay. We can combine those next. 3y plus 10 equals 5y. What am I going to do now? Cole?
You're going to subtract 3y from each side.
Perfect. Subtract 3y. And I get 10 is equal to 2y. Then I divide by 2, and y is equal to 5. If you did that in a different order, you should still get the same answer. Okay? So that is how we solve multi-step equations.